Good morning, everybody. We are back from our camping trip. It was a great experience, having been completely self-sufficient as far as power is concerned. And of course, I was complaining about the solar panel. Now, when we got home, I received another replacement solar panel in the mail. So I got my old solar panel, I got my new solar panel. I measured this solar panel, was outputting about 3.7 watts, making it probably an 80 watt solar panel and not 120. And the manufacturer has admitted that there must be some kind of issue in their process and that they were going to do a review. And this one that they gave me now, this is a 120 watt solar panel. So what I'm planning to do is I'm gonna test all of these. I got also a Noco Genius, which is a 7.2 amp charger. I got my cheap smart battery charger. So this is 3 times the price of this one. This one was about 40 bucks. This one's about 120 bucks Canadian. So divide that by 1.3 to get US dollars. I'm gonna compare these two and see whether it's worth it. Now, I did charge up the battery with the Noco Genius when we got home, and I drained it with my fridge, with my cooler that draws 5 amps, and I got to 12 volts, but I was actually able to do 12 and a half hours at 5 amps before I got to 12 volts. That would mean 12 and a half hours is probably like 62 amps. So if that is the case, if the Genius managed to put another 10 amps in, which it probably did because it was charging for quite a while after the solar panel stopped charging, then the Genius might be worth it. Now, the only problem with this charger is I'm not going to be able to use it on my inverter because it's 150 watt rated, so I don't even want to try it because I'm probably going to blow the fuse on the cigarette lighter socket in my car. So I'm going to continue using this one. Now there's an issue with this one. When I plug it in, all the lights start shining like it says it's 100% charged. So I'm not sure it's very reliable, but being rated at 100 watts is good, right? So 100 watt rating is good, and that works in my car. So I'm probably still going to use a cheap charger like this one. I am going to be returning this one just because the indicators are not doing what they're supposed to do. When you plug it in, it's supposed to just show no status. So let me just show you what's going on here. When I plug it in, you'll see that it just shows that it's charged, and this is incorrect, right? This is not something that should be showing on this, and this just started doing this at some point for no reason. So yeah, it still does charge. It does put out 5 amps. I have tested it. So I'm still gonna try and test the difference between if I charge the battery up with this one versus with this one to see how much I'm gonna get. And then of course I'm gonna also compare the PWM controller that came with the solar panels with the MPPT controller and see how differently they charge up the battery itself. So this is gonna take a few days to test everything out. Today we're gonna do the solar panels with the MPPT charger and see what happens when it says it's charged. I know when I charged it up before, it got to 12.7 volts on idle, so without a load, whereas with the Genius it got to 12.9 when idle, which means there's probably about, possibly about 10 amp hours extra that I can get in with that charger. And the Noco Genius does go up to 14.8 volts, which is what you should get from an AGM charger, and this one has a selection between the normal battery and AGM battery, 12 volt, 24 volt. You can do 12 volt lithium and 12 volt AGM plus, which are some batteries that charge at up to 15.5 volts, which is not what this one does. And then it's got a repair and a 13.6 volt 13.6 supply, which is just 5 amps at 13.6 volts, which is like a float charge that it automatically switches to whenever it's charging. Or it can just be a power supply, 13.6 volts, 5 amps. Anyway, this thing is nice, and I'm gonna keep it just because it's, you know, very well built. It charges up the battery fairly quickly, whereas this thing is good for the car when I just need to top up a little bit straight from that lighter socket, like I showed before in one of my previous videos. And then I'm gonna see whether it's worth replacing this PWM controller with an MPPT controller. This is much bigger, so what I'm thinking of doing it is sort of mounting it right here on the side and having it mounted on the side. That would of course give me a bit of loss and of space. Now the other option that I'm thinking could be an option is just actually mounting it in here and getting rid of all my crap and somehow mounting it here, but that's not good because this would warm up the battery, and maybe I'll figure something out with this guy. Maybe even mount this guy somewhere in the car, just on the wall of the car, and then keep the battery installed in the car, because probably taking it out isn't very efficient, and getting rid of the whole complication with you know, charging all this stuff. Now of course this one has a little bit of a different setup with the leads than this cheap setup, so if I switch to the MPPT charger, I'm actually gonna make these cables a little bit nicer, a little bit more different. Anyhow, let's get the whole thing set up here. All right, so here's the setup. I bought some Y splitter cables, so now I can plug both panels in, and I have 2 extension cords, and I've got my old panel, my new panel on the left and the old panel on the right, which you can see by these straps. The new one came without the straps, but you know, it's a free panel, so I don't care. So basically, yeah, now let's see what we're doing. It's a bit cloudy, so it's not gonna do much. 2.56. oh, it's sun, the sun's coming out from the clouds. That's good. 3.5. okay, so I need a bit more stability in the sun to get a good reading. And yeah, this is now gonna run for a little while, but still, you know, with the 2 panels, now I'm getting a combined basically 200 watts. All right, 200 watts, and let's show you, let's see the difference. So if I unplug this one, if I unplug this one, then I'm unplugging the new panel. There we go, I unplugged the new panel. Let's see the difference in amperage. 1.7 right now, 1.8. Let's quickly plug in this guy. Boop. 4 point something, right? So we're getting like 40% more power from the new panel than the old one. Now this measurement right now is not really reliable, but I did measure the amps for the panels, open circuit amps for both panels, and there was about 40% difference in the open circuit voltage. So voltage and amperage, well, no, same voltage, different amperage. So yeah, okay, let's do this. Let's see the amperage now. Yeah, 5.7, 5.5. I pulled about 62 amp hours off of that battery. you know, if right now it's morning still, it's 9 a.m. ish, 9:30 right now, so I'm not expecting a lot, but this is good. I mean, with full sunshine I'm getting like 5 amps from the 2 panels, so I do now have 200 watts of capacity, which is, you know, better than I expected, just because the manufacturer has a problem with the panels. Yeah, you know, that's what you get. Now, to figure out that problem, I did have to buy an MPPT controller. I did have to buy a voltmeter. So you know, I'm probably, you know, the voltmeter was 20 bucks, the MPPT was 125, so that's $145. But I do have these 2 things now to test other panels and to do other stuff. And this is 30 watts, 30 amps. So with a 24 volt system, yeah, I could get like 750 amps, 750 watts out of a 30 amp charger. So if I wanted to go bigger, I could. And yeah, this one has Bluetooth, so it's nice. And yeah, I did show that in one of my previous videos, and I'm gonna show you more when I get some results off of this one. This is doing pretty well now. We're up to 12.4 volts for the charging current, charging voltage. So let's see the charging current: 5.7 amps, 5.8 amps, 5.9. Yeah, this is a whole different setup. This new panel is really great. And yeah, I'm gonna thank EcoWorthy for sending me another panel. Not sponsored or anything, and I hope they do solve the problem with their manufacturing to get rid of the panels that don't they're not up to spec, because when you are buying solar, you want to know exactly how much your panel is outputting. You don't want to buy a 120 watt panel planned for 120 watts and then get 40 watts less of maximum capacity, just because that's gonna kill your whole setup. And I was struggling to maintain the fridge, well, at a low temperature. Once I got up to like 8 degrees Celsius, then, you know, I could easily charge up the battery for all the amps that the fridge took, except for when it was a bit cloudy and stuff. Well, then we went driving, and, you know, I had that set up with the cheap charger here, set up to an inverter, and that managed to charge the battery pretty well. Not fully, but I probably, in 4.5 hours of driving, we probably added about 22 amp hours, which was plenty for the fridge. The fridge at 8 degrees was only pulling about maybe 10 amp hours per night, and then I could easily replenish that 10 to 12 amp hours with the old solar panel. Now that I have 200 watts of capacity, I can pretty much run the fridge at like 0 degrees or even like a freezer, and I will be able to replenish that capacity. I just need to know now how much this charging system actually replenishes with the PWM controller and how fast it charges up, versus what happens if I put an MPPT on it, and, you know, how much of a difference there is. I really want to use this MPPT controller, because it does have Bluetooth and it does have that history, and it gives you information about how much you pulled out of the battery and how much you put into the battery every day, which is a great feature to have that I don't have on the PWM controller. But it is a little bit bulkier, so it will make my system a little less mobile. It's probably going to be tied to the car itself then. But due to the rain that we had, most days I just kept the battery in the car itself, so it doesn't really matter. It's an AGM battery. It doesn't off gas when you're charging it, so it's pretty safe from that point of view. Yeah, that's it. Thank you very much for watching. I hope you like my videos, and if you're willing to support my channel, I would love for you to subscribe. I'm still looking to increase the subscriber count to a certain point where I can do live videos, so I'll need 1,000 subscribers to do live videos off of my mobile devices. Right now, I mean, I can go mobile. I can take my computer with me, and I can stream off of my computer with a webcam, but I can't use my GoPro, which I would want to do live streams. And once I get to that 1,000 subscriber count, I promise that there will be more live streams, that I will actually be doing more stuff for as far as cloud computing goes, and as far as this solar sub project goes. So yeah, thank you very much, and please consider subscribing. I know 90% of you that watch these videos are not subscribed, and if another couple of you, another 5% subscribe, then we are at the 1,000 subscribers, and this channel is going to be much nicer, much more involved. So yeah, thank you very much, and I will see you in my next video. Bye.